So number 1, this one is continuous. This one is not. This one is not. This one is not. This one is not. And this one is continuous. So malalaman natin na continuous siya kasi, padritso lang ang graph. And this one. Padritso lang ang graph of that. Okay? So for each given combination of values of limit of f of x as x goes to c and f of c, we have to sketch the graph. Okay. In here, we have two graphs, but they have the same limit. When we have by direct evaluation, f of 1 is 3. By direct evaluation, f of 1 is 3. And here, the limit of f of x as x goes to 1, from the left is 2, from the right is 2 also. So the limit is 2, and by direct substitution, it's 3. Similar to this. Okay, so these two are discontinuous, or we call this one discontinuity. Is it necessary for us to usually look at the graph from the left and the right, or we are going to make a table of values from the left and from the right to identify the limit? Of course, there are cases na beneficial yun. There are cases na hindi. Lalo na pag if you are evaluating the limit or finding the limit, because filling in a table of values sometimes requires very tedious calculations. And for this, we will learn how to compute the limit of a function using the limit theorems. So the limit theorems are theorems that are involving polynomial, rational, exponential, logarithmic, trigonometric, and transcendental functions, as well as the special cases. So let's start with the find the limit as fast as you can. Okay, number 3, letter A. What is the limit? The answer for this is 10. Why? Because alam natin na papunta siya doon. Why not? Kung i-direct natin na substitute. So for example, as x equals 3. So that is 10 over 3 minus 2. That is 10 over 1. That is 10. So as x approaching to 3 from the left and right, it's really 10 because this is continuous. Yun yung beneficial. Kung identify na natin na continuous, that means we can directly substitute the value of the limit. Or we can evaluate the limit by substitution. Letter B, who can give me the answer?
2, sir.
2, that is 10 over 5, that is 2. Next, number 3.
Negative 5, sir.
Negative 5, correct. Very good. Letter D.
3, sir.
3, correct. That is 6 over 2. Very good. Next, letter E.
1/2, sir.
1/2 of 0.5. That's correct. Very good. Letter F. Pwede bang i-direct substitute? Mapansin natin na ang x approaching to 0. So therefore, saan ba ang 0 na belong? Dito, ang sabi niya, ang domain ay x is less than equal to negative 1. That means sa left ng negative 1. Yung mga values na negative 2, negative 3, yun. Ito naman ay x greater than negative.
Negative 2 po, sir.
Very good, negative 2. Kasi dito tayo titingin. Ang 0 kasi dito, yan siya na belong. So that means ito yung gagamitin natin na function. 0 minus 2. Okay? Letter G.
Negative 1, sir.
Negative 1. Kasi 1 squared minus 2, that is negative 1. As x approaching to 1. How about letter H? Anybody?
4, sir.
4.
2, I mean.
Okay, ito yung disadvantage. Alam natin na this one is not continuous. So, hindi natin siya pwedeng sabihin agad na the limit is this by direct substitution. Why? Kasi alam natin na ang limit ay discontinuous or hindi siya continuous. The second one is alam din natin na ang limit ay from the left and from the right. So, titingnan natin. Kung ang x equals 1 kasi, that means dito tayo titingin. So that means 2. Ito ba ay pareho dito? Or dito? Of course. Sa left ng 1, ay papunta siya doon sa 4. Kasi by direct substitution, doon siya sa 4. 0.999 plus 3, that is 3.999. Or approximately, papunta sa 4. And then sa right naman ng 1, dito tayo, example 1, that is 5, 1 minus 1. That is 2. Diba na? Kasi 4 minus 1, square root of that is, square root of 4, that is 2. So it means approaching to 2 siya. Example 1.001, ang kanyang value dito ay 2.0001. So it means ang kanyang limit from the right is equal to 2, from the left is 4. And if we are going to directly substitute, it is 2. So therefore, ito ang i-check natin, yung dalawa. So kaya hindi man siya pareho, it means the limit does not exist. The limit does not exist. Okay na ba?
Yes po, sir.
Yes, sir.
Okay. We are now ready to list down the basic theorems on limits. We will state 8 theorems. This will enable us to directly evaluate limits without need for a table or a graph. So number 1 is, in the following statement, C is a constant. So when you say C is a constant, that is a number. And F and G are functions. When you say functions, dapat 1 to 1 at the same time, many to 1, which may or may not have C in their domains. So, not necessarily na yung C ay belong doon sa domain ng F or sa domain ng G. So, in this theorem number 1, the limit of a constant is itself. If K is any constant, then the limit of K as X goes to C equals, example, limit of 2 as X goes to 0 equals 2. The limit of 2 as X goes to 9 equals 2. Because the limit of a constant is equal to the constant itself. As X goes to any real number. Kahit ano pa dyan, kahit sabihin pa yan, as X goes to 1 million, what is the limit of 2? 2 pa rin. Limit of negative 3.14 or negative pi as X goes to any real number is equal to negative pi. The limit of 789 as X approaching to C is equal to 789 for any real number X. So that is the limit. Any question? Any question
Wala.
with that? Okay, next. Number 2. Tandaan ha, yung limit of a constant is constant. Kasi, pag mapunta tayo sa derivative, confused na tayo. So, ang limit ng constant ay yung constant lang. The limit of X as X approaches C is equal to C. This may be thought of as the substitution law. So, by substitution, because X is simply substituted by C. So, direct substitution, because kung X ay polynomial function, or say polynomial, it means yung domain niya ay all real numbers. That means for all real numbers, C, it means that is equal to C. So, ang limit, example, limit of X as X goes to 9 equals 9. Because by direct substitution, 9 yung result. The limit of X as X goes to 0.005 is equal to 0.005 because it is continuous. Number 3 naman, the limit of X as X goes to negative 10 equals negative 10. It's because by direct substitution, and that is continuous at that X equals negative 10. The number 2, by direct substitution. Sa limit theorem number 3, if for the remaining theorems from 3 to 8, we will assume that the limits of F and G both exist as X approaches C, and that they are L and M respectively. In other words, the limit of X equals L, and the limit of G of X equals M. So, i-close muna natin yung shinare ni John Ken. So, the first is constant multiple theorem. So, ito yung sabi doon. What if may multiple na, may multiplier? So, i-multiply lang din. K limit of k times f of x as x goes to c equals, pwede natin ilabas ang k times the limit of f of x. So, kung ang limit of f of x are L, that means you multiply that one. Example to that is this. The limit of a times f of x as x goes to c. Ang f of x natin ay 4. So, it means ilalagay natin ang 4 times 8, that is 32. The limit of negative 11 as x goes to c times f of x, of course, we have negative 11 times 4, and that is negative 44. Number 3 naman is limit of 3 halves as x goes to c times f of x equals 3 halves times the limit of f of x as x goes to c. So, ang f of x natin ay 4 as x goes to c. 3 halves times 4, that is equal to 12 over 2, that is 6. So, sa addition naman, when we add, of course, automatic, the limit of a sum of functions is the sum of the limits of the individual functions. So, the limit of f of x plus g of x ay isa-isahin natin. So, limit of f of x. So, itong limit of this one, as x goes to c, parang na-distribute lang din siya. Limit of f of x as x goes to c plus limit of g of x as x goes to c. Alam natin this one is L, alam natin this is M, so that is L plus M. If that is a subtraction, then that is subtraction also. Example, limit of f of x as x goes to c is 4, and limit of g of x as x goes to c is negative 5. So when we add 4 plus negative 5, that is negative 1. When we subtract 4 minus negative 5, that is 9. And this is the multiplication theorem. When we multiply, of course, limit of f of x times g of x, we multiply also. When we divide, example, multiplication na tayo. Limit of f of x as x goes to c times times g of x. Of course, kung ang limit of f of x ay 4, and limit of g of x ay negative 5 as x goes to c, then the product is equal to negative 20. So, parang nagmo-multiply lang din tayo. Remarks, the additional multiplication theorems may be applied to sums, differences, and products more than 2 functions. Pwedeng f of x plus g of x plus h of x, at so on, pag marami na masyado. The constant multiple theorem is a special case of the multiplication theorem. Indeed, the multiplication theorem, if the first function f of x is replaced by a constant k, the result is the constant multiple theorem. Next is the division theorem. This says that the limit of a quotient is equal to the quotient of the limits, provided that the limit is not equal to 0 sa denominator. Example ito. Provided na yung limit doon sa denominator is not equal to 0. M must not be equal to 0. Pag mag-equal sa 0, it means it is undefined. Or the limit of f of x as x goes to c, as example, equals to 4, and the limit of g of x as x goes to c is equal to negative 5, then the quotient is 4 over negative 5 or negative 4 over 5. And if the limit of f of x equals 0 and the limit of g of x equals 5, so the quotient is 0 over negative 5 or 0 over 5. Bakit may negative na ito dito? Dapat negative 5 din dyan. Okay. So that is equal to 0. Ang limit of g of x, f of x equals 4, and the limit of g of x equals 0, it is not possible to evaluate this one, or we say that the limit does not exist. This one, the limit does not exist. Ay, clarify ko lang na walang limit na undefined ha, kasi defined lahat ng limit pero does not exist yung result pag the denominator is 0. Mag-undefined lang tayo doon sa evaluation ng ating value sa functions. Pero ang isusulat natin kung 0 ang denominator is, does not exist. The power theorem, kung may exponent tayo, so we will do the law of exponent. Example, 4 cubed, limit of f of x equals 4 and limit of x goes to power of 3 as x goes to c. So that is 4 cubed, that is 4 times 4 times 4, that is 64. Similar to this as limit of x f of x equals 4 as x goes to c. F of x goes to negative 2, that is 4 to the negative 2 or 1 over 16. So, kung negative ang exponent, ganun pa rin, loss of exponent pa rin gamitin. For the last theorem, the radical or root theorem, this theorem states that if n is a positive integer, the limit of nth root of a function is just the nth root of the limit of the function. So, kung square root yan siya, sa square root pa rin tayo. Sa limit tayo mag-square root. Hindi yun sa, I mean doon sa L. Okay, the nth root, pansin nyo na this one, the limit of the nth root of the f of x is equals to the nth root of the limit of f of x. So that means para siyang sa sine cosine na ano siya, pwede ang radical, ipasok natin lahat na nasa f of x. Okay. So that is the nth root of L. Example to that, kung 4, that means the limit of this is 4, so the answer is 2. Negative 4, of course, is not a real number. It is not possible to evaluate. So, the limit of f of x as x goes to c equals negative 4, so we say that this is the square root of negative 4, and this is not a real number. Anong isusulat natin? Equals to square root of negative 4 lang. Hindi natin sabihin na hindi siya does not exist. Kundi, ang isusulat natin is not a real number. Okay? Question with the 8 theorems.